right, you guys, today we're finishing up chapter 1 with a very basic introduction to functions and ordered pairs. A function is actually, and I will show you a video probably, if not next week, then when we will come back to functions a little bit later. But a function is simply a way of pairing numbers together. Okay, we would call them equations, but it's a way to pair numbers. So, learning targets. After this, you'll be able to define function vocabulary and plot points on a coordinate plane. Hopefully, this is review for you. Okay, so please draw and label a coordinate plane. And I'm going to press pause. Put everything on here that you know about graphing a point, graphing an ordered pair. Okay, I'm going to do it quietly, and you guys try not to. Alright, so make sure you have these things labeled. The coordinate plane is made up of two intersecting lines. Lines are one directional. They go just off in one direction. A plane, remember, is a two-dimensional flat surface, like a piece of paper that goes on forever and ever. And then when we get into 3 dimensions, we would call that space, coordinate space. And those of you that are interested, and even if you're not, I'll probably show you later how we graph in 3 dimensions. You'll do that, I think, in pre-calculus or calculus. Make sure you recognize the word origin. And where kids have the most trouble graphing is on the axes. They get mixed up if they go over or if they go down first. Okay? Alright, we just talked about that. We talked about those. We talked about quadrants. Let's do ordered pairs. Just go ahead and sketch a coordinate plane in your notes. Some of you like to have them all, the axes completely numbered. I can actually sketch a graph without numbering, and I just put like little hash marks. So if this were my notes, this is what it would look. Whoops, what the heck is that there for? If this were my notes, my graph would look like this. I don't need it numbered. I know where the positives are, the negatives are, X and Y. But if you want to, go ahead. I'm going to press pause, put those 4 points, and let's label them. Points are always labeled with capital letters. That way you don't have to put the ordered pairs in the graph. You can just put A, B, C, D. Hopefully that is review for you guys. Is that right? Okay, great. Like I said, watch the axes. Sometimes they would kids accidentally put something that should be on the y-axis onto the x-axis. By the way, if a point falls on one of the axes, it is not in a quadrant. Okay? It is on an axis or an axis. We'll get to that later. Here's a vocabulary word I want you to know. Inputs and outputs. This is really function language. Because a function, we talk about putting something in, substituting something into the equation, and you get an out. Often in algebra, linear algebra, we talk about x and y. We pick an x, do some work, the function's like the machine that does the work, and spit out a y. An input is what goes in for x, and output is what comes out for y. And then we show that relationship as an ordered pair. Generally, we put the ordered pairs alphabetically, but if it's a word problem and your variables don't fall correctly, we always, in an ordered pair, do the input, comma, output. Okay? An ordered pair, by the way, don't mess this up because I'll take off points, has a comma, otherwise it looks like a 2-digit number, and it has parentheses, otherwise it just looks like 2 numbers. Okay, so make sure that you're careful about that. This, though, should be new language. Domain and range. This is not the statistical range, the high, minus, low. This is different. The domain is the set of inputs. It's what numbers you pick from. The set of inputs. And we show sets, and I didn't point this out when we were classifying numbers, but when we are listing sets, we use these funny brackets. If you have trouble drawing them, when my daughter had Mr. Hansen, he taught it really well. He said it's an S on top of a 2. And then the set of inputs, you're going to have some list, some set of X's that you put into the function. And this bracket is a 2 on top of an S. Set notation uses those squiggly brackets. If you can't make them, at least put squiggles. Do not put parentheses around a set. And then the domain, if I bet you can guess, is the set of outputs. Thank you, I mean range. The set of outputs. So a set of all of the Y's that you can get. Sometimes we list them. Sometimes it might be a larger set. If I had a function that dealt with cats, could I use any number I could imagine if I was talking about the domain being cats? Could I plug in anything I wanted, Simon? No, what numbers wouldn't I want to use? Rational numbers? I don't want 1.5 cats. Ew. Okay, probably not negative cats. Well, cats do get a little sassy, maybe if they had a negative attitude. But, so these domains and ranges will change. All right? So, often we will make a table to do our domains and ranges. You'll eventually get, well, maybe you will. I actually was taught to do a T-chart. Okay? You might get there where you don't put the rule in and you kind of do it either in your head or in scratch paper. But let's go ahead and fill this out for a while. So these are the inputs that have been chosen for you. I'm just going to simply fill this in as plugging these in for X. I'm going to press pause, go ahead and complete this table. So then in algebra, especially once we start really getting into functions, again, this is just an introduction. The next step usually would be to plot the points. What was that? Let's see, 115, I think, 0, 5, and -1, -5. So go ahead. I'm going to count by 5s going up the y-axis. So 2, 5, 10, 15, 20, 25. 1, 15, 2, 0, 5, and -1, 5. Say it again. The graph, yes, I want you to at least sketch it. Okay, have a coordinate plane and the line in the correct direction. Now, 2, 1, 0, -1, and remember this function was this. Those were picked, but could I pick, if this is just numbers, it's not about cats or anything, could I have picked 0.5 to put in for X? Could I have figured out what that was? Could I have picked 1,000? So when we graph a function, we connect them to show we mean all of the numbers in between those that we picked, and we put arrows in to show, well, I could have picked numbers beyond where my line is. It goes on forever. All right, I think I just have one more word problem. Oh, no, got to do this one. So make a quick table. Here's the function. Y equals the absolute value of x minus 4. I'm going to just do this quiet. You can just go ahead and plug in 2, 3, 4, 5, and 6. All right, so hopefully you got this V. I knew right, oops, darn it. I knew right away that this was going to be a V. And if you can remember that, any function that has a absolute value will always give you a V, because you can't get a negative out of an absolute value. So it can't go into the y's unless you put a negative out front of it. Then the entire V would be upside down. All right, so I just want to talk about a real life problem, okay? Here's a situation. The number of chaperones at a school field trip must be 1/5 the number of students attending plus 2 teacher sponsors. Write a rule, so write a function for the number of chaperones that must be on the trip. So chaperones is your output. That's what you're trying to figure out. How do I find out how many chaperones I need? I take 1/5 of how many students, and I add 2 more teachers. This is a function where my inputs are the number of students and my output is the number of chaperones. I'm not even going to do the math on this. Okay, but I just want you to be aware of writing real world situations. That's all I got. I make sure you get the worksheet, and it'll be way easier.